All right, welcome back to the security track. We're going to start off with a talk on OpenTitan. My name is Jeff Andersen, engineer from Google.
And my name is Miguel. I'm also from Google. Let's get started. Thanks everyone for being here. So the presentation today is focused on the LGray implementation of OpenTitan. LGray is an external root of trust, which we're planning to introduce in the data center. We will go over some of the use cases of OpenTitan and multiple configurations. There's also a whole set of use cases outside of the data center focused on client, mobile, and IoT integrations. In those integrations, OpenTitan is also used as a discrete root of trust and also as a secure element. OpenTitan implements countermeasures against side channels and fault injection, and we're aiming to certify the silicon against common criteria. So it will meet the highest level of physical hardening for those use cases. And this is the first version of OpenTitan Silicon. It's sold by Nuvoton. So if you guys are interested, you can stop by Nuvoton's booth to get more information. This is the current configuration. We support up to 1 megabyte of embedded flash and 128 kilobytes of SRAM. We support features that are aligned with OCP security requirements. We will go over that in more detail in later slides. We're also continuing to work on the OpenTitan roadmap for discrete roots of trust. So if you guys are interested in providing inputs and discussing your requirements, if you're interested in collaborating, please reach out and we'll make sure to take your inputs into account. So I'm going to hand it over to you.
So in OCP, we've often characterized roots of trust as wearing a number of different hats. It's not just a root of trust, it's a root of trust for X, where X can be identity, measurement, update recovery, or even storage. And OpenTitan is designed to satisfy all of these use cases. So for identity measurement, it can measure the firmware configuration of firmware before it loads, calling out that Calyptro fulfills this role for SoCs with integrated roots of trust, but without an integrated root of trust, you can have this property with an EROT with different security and deployability properties there. For update, you may want to have assurances that only signed firmware can ever land on your platform. And so this involves signature checks, anti-rollback enforcement, making sure that you can recover hardware even though the firmware might have been corrupted, and root of trust for storage, where you're holding secrets for the platform bound to certain configurations, as well as monotonic counters that can have a wide variety of different use cases. Zooming in on update and recovery. So as I mentioned, we need signature checks to make sure that when an update is presented, that the signature is valid before it is actually applied to your flash. We need to be able to enforce anti-rollback so that even though old images might have been validly signed, they are no good anymore. And that allows you, the anti-rollback here allows you to get that property without having to roll all of your keys every time you discover a bug in your firmware. As well as targeted debug authorization as well, is another feature that lets you manage your platform in a mostly locked down state, but opening up only if and when you need to. Now, I'm calling out here flashless boot, which has been talked about a lot in OCP. I believe there's a talk later this session about that. It's a critical part of the roadmap, and it cuts down on a lot of the need for all these stateful flash chips around your platform and RTUs needed to guard them. But in many cases, it's still going to go down, like the turtles stop at some point, and you'll have something like a BMC, which has a flash chip, which needs to work for the platform to be operational, and it will need an RTU for itself. New use cases related to platform availability, like I2C interposing. Say you have a BMC responsible for managing all the voltage regulators on your platform. If the BMC has a runtime compromise, it could potentially melt down your system, causing permanent physical denial of service. Yeah, cool, you attested that the boot code was legitimate and intended, but a runtime compromise still made the system a brick. We can route I2C through components like an EROT to have a very minimal TCB to ensure that only valid configuration can get pushed to these sensitive components. And for storage, so securely holding secrets and counters. Google does this at scale. We provision the equivalent of mutual authenticator TLS credentials to all of the nodes in our fleet, and we seal them to a policy such that it can only be unsealed if the platform booted the code that we intended to boot. And this policy is enforced locally at the root of trust for storage. Now, this kind of requires internal flash and minimal TCB to have your counters and your anti-rollback state. An API that serves these properties is the Trusted Platform Module, or TPM. It's not the only such API that can be used to get these properties, but it's a common one, and it's one we're pivoting towards. And OpenTitan will support dice-based attestable TPM, so you can even recover from vulnerabilities in the TPM application layer, which is a new spec that TCG put out recently.
Okay. So this is a proposal for integrating the OpenTitan into a platform. And we're basically, we're fulfilling two primary use cases. There's an OpenTitan root of trust in the DCSCM space. And then there's also attached to the main SoC. So for demonstration purposes here, we're just referring to the application SoC as the main processing unit in the system. And we're basically using the OpenTitan instance attached to the BMC to provide root of trust services for measurement, update, and storage. And then on the application SoC, we're planning to integrate OpenTitan with an IROT, such as Calyptra. And in that case, we're only fulfilling the root of trust for storage functionality. So I guess this is leeway, but what if there's a BMC and what if there's a Calyptra in the BMC?
Right, so in that case, the BMC has its own RTM. That's great. We've defended against physical interposers. The OpenTitan still has its uses as root of trust for update and storage for the BMC. So we need to make sure that only signed updates land in that EEPROM. Now, OpenTitan here is interposing on the SPI lines, and this is something we've done for a while. It's not the most fun thing to make work with every new platform. SPI was not a protocol that was intended to be interposed upon. So there's a lot of little gotchas and problems and quirks there. But now that we're not in the RTM business here in this integration, we don't actually have to be a SPI interposer. We can instead be off on the side. This is a side-by-side RTU integration with an AB scheme, gated by a MUX, and OpenTitan still is in a position to enforce all of the RTU and RTS properties without having to actually be in the critical SPI path. So OpenTitan can be RTU for the BMC, and BMC can be RTU for everything else. Imagine we're booting over I3C using streaming boot or flashless boot. So this is how this can look.
Okay, so, and then this is the last part of the presentation. So we're aiming to align as much as possible with OCP requirements, integration requirements. And so we're working closely with the community to put together a reference stack providing some of the middleware and application functionality needed to meet those requirements. And so we'll be working on this implementation with other partners, and that will be part of the call to action. If you guys are interested in getting more details, please do reach out. We can have a chat. So some of the previous presentations that we had earlier today are incorporated into this reference stack. I think I will let Jeff speak to that with respect to SPDM and a testable.
Oh yeah, so there's different libraries listed right here, and it would be nice to have open reference implementations for memory safe language like Rust. TPM has, or TCG has a nascent, not so nascent anymore, effort called TPM RS to do essentially a from scratch implementation of the TPM library in Rust, not the client layer, the actual implementation which would go on the device. So that's really promising, and we hope that effort succeeds. Other things like SPDM, there's reference implementations out there, so we can use that for attestation. Call back to the authorization topic that was given earlier. We also have ownership transfer. This is a thing that OpenTitan supports natively, and it is aligned with DOT from OCP, and we aim to see how we can get it fully integrated into the published DOT spec.
Great. So yeah, so call for action. So it's a bit of a cliffhanger. So as we start working on the reference stack, we'll be engaging with the community. More details to come in the next OCP regional summit. And then please also give it a try. And so there's OpenTitan Silicon available now, today, that you can request via Nuvoton. There are also FPGA emulation platforms. We're also putting together QEMU implementation to facilitate explorations. Yeah, that's all we have. Thank you.
Yeah. Any questions?
Hello. The OpenTitan is a platform root of trust, right, for the data center. The PROT.
In one of the use cases we presented, it is indeed used as a platform root of trust.
Yes.
By itself, OpenTitan cannot fulfill all the functionality of a platform root of trust, so we do have to engage with the BMC.
Okay.
But since we are the root of trust for measurement and update in BMCs that don't have support for IROTs, it is effectively equivalent to a platform root of trust.
So when it is used with Calyptra, that time the Calyptra is providing this root of trust for identity and root of trust for measurement, and Titan is providing root of trust for storage. Is it the correct understanding?
Yes, that's a very close approximation.
Yes.
So we have a couple of different integration modes. There's one which doesn't have an IROT in the BMC. So as you can see, that's the initials there. Root of trust for measurement, update, and storage for the BMC. And then on the other side, it's just root of trust for storage. So the boundary of the DCSCA card just becomes, in a way, proxy to the platform root of trust in this example. So
we want to move towards, putting Calyptra anywhere it can. So we'd bias towards something which like this, and then from here towards more something which looks like this for simpler integrations, where OpenTitan is just RTU, RTS, and then.
And then just in terms of full disclosure, right? So Calyptra is also a very active project, right? And in development, so there is a roadmap. And as you saw in the previous, if you were there in the previous presentation, there's a Calyptra subsystem that supports an MCU. So there's a bit of things that will be, discussed, right, as part of that, right? So at the end of the day, I think we can, at least on our end, we are agreeing that there needs to be a root of trust for storage. And that's kind of the trend we have on our end. But there are some active discussions and conversations to be had with respect to where all the roadmaps are trending.
Thank you.
Going back to kind of the roots of OpenTitan, I'm assuming if a BMC vendor decided they would like to put OpenTitan integrated tightly with the BMC, that would be okay, right?
Want me to take it?
Yeah. Now, when you say integrated tightly, I think you mean like in package?
Yeah, in package, could be same silicon. It still performs all of the root of trust functions, and it could be part of the secure boot of the BMC, but it could be integrated inside of that device. There's nothing prohibiting that, right?
So an OpenTitan with NVM with embedded storage?
Yeah.
Okay. Yeah. I think if it's reasonable for the BMC vendor to implement such a configuration, I think it would be.
It'd be also something to talk to your customers about because they might prefer one implementation or a different one. So. Of
course.
Yeah.
But there's nothing preempting it. That was my main. From an OpenTitan perspective, there's no rules to stop such from happening.
No, there are no rules. Yeah.
So it looks like OpenTitan has RTI, or root of trust for identity, and root of trust for measurement. I'm just wondering, is it same as what you have in Calyptra, or what are the differences between those two, if at all, anything?
So we're trying to align at the specification level. So we're following TCG specs for attestation. And that's basically where things stop. Like implementation-wise, Calyptra has its own implementation. And if you want to be Calyptra compliant, because of the hardware interfaces and because of the way things are implemented, I think it's the guidelines are that you have to take the RTL and the software to be able to implement that functionality. OpenTitan is not based on Calyptra, so OpenTitan started before Calyptra got started. So we are aligned at the specification level at this point in time.
From the outside the box perspective, we'd like to see SPDM and TPM APIs supported, and then these are different ways to slice how those layers get implemented.
Yeah, and one other thing to note is that OpenTitan has another set of use cases that are not part of the data center, where we have to care about common criteria certification requirements for physical security, so physical hardening. And so that makes it hard for us to align on a short timeline. So I think for now, you will see OpenTitan having its own roadmap as well.
So you mentioned TPM APIs supported by OpenTitan. Does that mean it does implement like the full set of TPM commands or some subset, or what do you mean by the TPM API support in OpenTitan?
And the goal would be to be able to interact with it as a TPM.
So it would be like a compliant, just a TPM 2.0?
Yeah. Now, there's been talk about data centers don't really need the entire PC client suite of functionality, and is there a way to trim that down? Discussions there are, but we're still talking about it, but.
Yeah, so we're aiming to get the TPM RS implementation integrated into the stack. So that would be the goal on our end. We have existing integrations for OpenTitan in other spaces where we support a subset of the TPM spec. So for client specifically, that's what we do.
Okay, thank you very much. Appreciate the questions.